Hello everyone, welcome to my channel. Here I'm gonna share my experience working on high traffic websites such as wheelfortune.com, rewards.sony.com. I worked on different Sony websites for 8 years, and here I want to share my experience how to work with databases. I start with databases, and today I want to share some basic stuff about indexes. Not everyone knows how easy to understand what's going on, how easy to understand performance problems. Let's try run just a simple query which selects some data from member table where we are searching by, for example, by email. Member in my database, it's a database of membership where we store people who register on the site, and that's a pretty popular query, I think, to find people who are registered. When we log in, we need to find people by email, and that query should be pretty popular. Let's try no reply. I have one user with this email in my database. Prof web dev. The email doesn't exist. If you try send something, doesn't exist, but domain is actually exists. That's my domain name. Let's try run this query. It runs fast. If you check the performance, 0 seconds, incredibly fast. And someone can think, yes, it's running 0 seconds. I can go to production. I can start using this query on production. Maybe it will run fast for some websites where you don't have high traffic, but with a high traffic website that might be a problem, and we can check this. To see the problem, I usually look at statistic first. To see statistic, we need to set some parameters on the database, on your connection. These parameters are for current sessions. If you set it, it affects only current session. If we close connection and open again, we need to set these parameters again. Okay, let's start set statistics IO on. I want to see statistic input output run, and I want to see time. Time is more accurate than we see on the bottom right corner. And let's see what's changed. Now we turned on these two parameters. Now when we execute this query, we can go to messages tab and see more detailed information what happened. The query actually executed 376 milliseconds. It's still fast. It's still less than a second. That's pretty fast for such a small database, and under small pressure this query will run, but it still has a lot of logical reads from the data. That's how many reads when database tried to find data. That's because we don't have any indexes. I can prove and show you I don't have any indexes on this database. That's just a simple database where we have lots of different things. And let's see where member indexes. I can refresh, nothing, 0 indexes, only primary key. Now let's see what happens when we create an index. Let's save this information for future to compare. Let's create an index, create index IX member. I usually see this pattern when people create indexes where we have IX prefix, then table name, and then columns, WS email on member table, and we want to index this table by column WS email. Let's see what's changed. Creating this index. It will take some time because when I record, anyway, it's fast, it's pretty fast. I'll save it for now, and let's execute the same query. Still 0 seconds. Nothing has changed. Why did we create an index if it's still 0 seconds? Let's check the messages tab. And here we go. We have only 7 reads, Elapsed time, 9 milliseconds, just 9 milliseconds to find this row in the database. With such a performance, SQL Server database will be able to handle more requests, more data, more traffic. It will work much faster. The first thing what I'm looking at when I need to optimize something is logical reads, and it shows me there might be a problem. If there's a huge number of reads like we had before creating index, that means there is no index. We don't use database efficiently. And for such a column like email, it actually makes sense to create an index. So even if you see performance 0 seconds on the right bottom corner, it doesn't mean the query is actually fast and will be able to handle traffic. Check statistics, how fast, how many logical reads, and how much actual execution times was in milliseconds. Okay, let's check the execution plan now. What happens with such a query? If we can include actual execution plan by clicking this button. Now running the query, and we should see one more tab, execution plan. Let's see what's happening when we execute such query. First, we search index-seek. We search for the row by email. If you check on the bottom, there is object ix member ws email, the index we just created. The output is ws email. Now we need to go to the same table, to member, but this time we search by primary key. So 2 searches. The first one is find by ws email, the second one by primary key. Why is that? Why do we need to search twice? When we search by ws email, we can use index and we can find the data, but this data inside the index will contain only ws email and primary key. Only WSML and primary key. If we need to see anything else other than that, database will need to go to the actual data location where the whole data stored and find everything else. Let's execute only this query. And execution plan should be simple. Search by index. Index already has WSML and primary key. That's enough. As soon as we add something else like WS first name, which doesn't exist in the index is only by email, we start having the problem with double search. First find the row by index and then find first name in actual data location. What we can do here, we can include information we actually need inside the index. Let's return back to our index. Let's drop this one. We don't need this anymore. We will create a new one. Drop index on member. Now create a new index. I'll comment out. We index by WS email and include. We do not actually index. We just store additional information with index. We just store. We do not actually index. If you don't search by this column, just wanna add this, just wanna be able to get information with the index, it makes sense to include. There are different hints that shows you when you wanna index and when you wanna just include. We will talk about this later in the next video. But first, WS first email, we are not searching by this. That's the first sign we should not index by that. WSML, no search, no need to index by that, but we can include. If we create such index and search again, our execution plan will be simple again, because we search by WS email in this where statement. We search by WS email and WS first name included with the index. We don't need to go to the actual data location and find this data. We can just return it right away. So that's one of the reasons why we should not select everything. We should never select everything. If you have select everything, you cannot include all the columns inside the index. It just doesn't make sense. You will have 2 copies in actual data location and with index. That's double storage. It affects performance as well. So never select everything. Select only stuff you need. If there is something you always select, like first name or maybe encrypted password, it makes sense to, when we authorize people, encrypted password as well. In this case, it maybe makes sense to include this column with the index, so we don't have this double search inside the database when database searches for information. But what if we search by both of them? By WS first name and WS first name, which one was first name? Okay, equals this one. Let's search how it affects performance. Now I search not just by WS email but by first name as well, and the database is not indexed by this column. Let's check the performance. Oh, we are looking for encrypted password as well. If you saw encrypted passwords here, they are not real. That's just dumb password. They are not real. Do not try to steal it. It's nothing to real information. No, I'm not gonna show you. Just trust me. That's not real passwords. Let's execute. Look at the execution plan. Even so, we filter base this information. The execution plan is still simple and the performance is fast. We need to index by columns which are unique enough. Email is unique enough to easily find information. First name is not that unique as email. When we compare two columns by which one to index, we need to choose the one that's more unique. If we search by, for example, sex, and sex, I don't have this column, we don't store this personal information, we don't care about that, and people should not care about that these days. If, for example, someone tries search, there is not that many variations, and indexing by sex doesn't make sense. If you want to choose by which column to index, it's better to choose the one that's more unique. Likes. Some people think if we use like, the database will not use indexes. That depends. If we put wildcard at the end, it will use indexes. Let's search and check the messages. The logical reads is still free. Even so, we have like, logical reads is still free. And execution just use indexes. If you check on the bottom object area, it shows that we use index IX member WS email. But if wildcard is in the beginning, let's put it in the beginning. Find all emails with this domain. That might be slow. And let's say logical reads is 9/16. We will still see the index. You see, we still use index, but it's not seek, it's scan. Why is that? I think I need a different video to show you why it's a different story. It still uses index, but still not that efficient as it could be if the wildcard is at the end. So index help even if you have wildcard in the beginning. Even if at the beginning it helps. As you see, the number of logical reads is way lower than we had in the beginning. Execution time is faster than we had when we didn't have an index. Let's drop and see. Let's save. And I'll prove you. Let's execute this query now and execute this one with no indexes. Let's see the performance. See how many logical reads. Now database needs to scan the whole data tree, the whole data storage. It's more expensive. It takes more time. But if we have index, even so we have a like and wildcard in the beginning, we search by index which has less data, which is smaller, which is easier to scan and find the right data, and it's faster. So indexes can help even if you have wildcard in the beginning and if you use like. Next thing you need to know when you use indexes, your data type should match. Let's create a variable. Declare a variable. Let's call it email, and it's gonna be varchar equals and this email. Now we are going to search by this email equals, and let's see what happens. And varchar. Yes, we found. Let's see what's going on in terms of oh, we don't have index. It's still logical reads. I forgot about index. Let's return it back. Let's return it back. Returning back index. We have index. It should be fast. Now we have index. We should be fast. We should not see that many logical reads. Let's verify what happens. We still have lots of logical reads. Even so, we have email index. We still have lots of logical reads. Why is that? Why is that? The problem is there is no match in data type. WS email has varchar type, and we are searched by nvarchar. That causes an issue. When we join or search by something, data types on the left side and on the right side should be compatible. If there is a difference, the index will not work. Let's make it varchar and see again 3 logical reads. Just by matching type, we were able to speed up query significantly. So when you write query, make sure you use compatible data types. If your parameters nvarchar, the data type you are filtering by should have exactly the same type nvarchar. If you have varchar, it's going to be a problem because SQL Server needs to convert data, and it converts this side, not the right side. We can help. We can actually help server and tell, hey, this one is not nvarchar, it's varchar. We can cast it and cast as varchar on this side. That might help with performance. See 3 logical reads again. That's possible. And we tell convert right side, not the left side. We can help SQL Server, but it's not always a better solution. It's easier and better declare variables with the same data type as it is in the database. That's all I wanted to show for the first video and share my experience working with SQL Server, show you the basic stuff about indexes. Later in the next video, I'm gonna show more details about every aspect we just quickly discussed in this video. Give it a like if you like this video, subscribe for my channel if you like this. Have a good day.